Hey guys, so here's your guys' notes on our lecture video on complex numbers and powers of I. So students will be able to add, subtract, multiply, and graph complex numbers and simplify powers of I. So the definition of what a complex number is any number that can be written in the form of a plus bi, where a and b are real numbers. It is the set of all real numbers and imaginary numbers. A plus bi is considered to be in standard form. So this is going to be key pretty much, you guys, that form, a plus bi, because that is the form that a lot of our answers is going to be in. So a is what we call a real number, and this is going to represent your guys' imaginary. So we are going to be delving in using real and imaginary numbers, okay? And it has to be the real number first and then the imaginary, a plus bi form. So we have this unit called I. So imaginary number I. I is an imaginary unit for which I equals radical square root of -1. And I to the second equals -1 by definition. Okay? So I to the second power, you guys, is equal to -1. Now when we add or subtract, you combine like terms. The real parts with the real parts and the imaginary parts with the imaginary. So as you guys can see, example 1, we have to combine like terms. But first, what we're going to do is we're going to distribute this negative signs to both of these on the inside. 4 plus 6i, a negative times -3 is a positive 3, and a negative times -7i is a positive 7i. And now we combine like terms, so 4 and 3 is our real numbers, you guys, and our imaginary is 6i and 7i. So combine those with the reals of reals and the imaginary with imaginary. 4 plus 3 is 7. 6i plus 7i is 13i. And it always has to be in the form of standard form. A plus bi, the real number first, and then the imaginary. Okay, part B. Now, there's a plus sign in the front of this, you guys, and when you guys distribute a plus to the inside, it doesn't matter, right? Because the signs aren't going to change. So what we're going to do is we're just going to drop the parentheses. -4 plus 10i. And then identify which ones are you guys' real numbers and identify which ones are your guys' imaginary. So 9 minus 4, because those are real, that's 5. 3i plus 10i, that's 13i. And again, it has to be in standard form. The real number plus the imaginary. A plus bi. Now, when we multiply complex numbers, you guys use the distributive property, and then you guys simplify. So when you guys have multiplication, you know it's multiplication because it's parenthesis. This is multiplication. So you guys do what we call a double distribution. You're going to distribute the -2 to both and the 5i. So -2 times 3 is -6. -2 times -8i, that's positive 16i. 5i times 3, you guys, is 15i, because we're doing the red. And 5i times -8i, you guys, is -40i to the second power. So all of this looks fine except the I to the second power, right? This is something that you guys are kind of like, what is that? Well, look at our definition of the imaginary unit I. I to the second power, you guys, is equals to -1. So this I to the second, you guys, we're going to cross that off, and that's really -1. So I'm going to rewrite everything except what is -40 times -1? -40 times -1 is positive 40. And then you combine your guys' reals together, and you guys combine your imaginaries together. -6 plus 40 is positive 34. 16i plus 15i, 31i. And there's your guys' answer. Double distribution. Make the I squared a -1 and then simplify. A plus bi form has to be in standard form. Okay, over here. Double distribution. 3 times negative 4 is negative 12. 3 times negative 9i, that's negative 27i. Now, 2i times negative 4 is negative 8i. 2i times negative 9i, you guys, that's negative 18i to the second power. But remember, I to the second power is negative 1 by definition. So, I'm going to rewrite all of this. But then, you guys, what's negative 18 times negative 1? Negative 18 times negative 1, positive 18. So, combine like terms, right? The reals and the imaginaries. Negative 12 plus 18, that's 6. Negative 27i minus 8i, that is negative 35i. And that is how you guys multiply your guys' complex numbers together. Okay, so we're here. Okay, so when you guys graph complex numbers, you gotta use standard form a plus bi in order to graph complex numbers. The a is the real and the b is the imaginary. The real axis is your x-axis and your imaginary axis is your y. So this is your guys' real axis and this is your guys' imaginary. So graphing should be pretty quick because if we look at part A, you guys, remember this is your real and this is your guys' imaginary. So if it's plus 5 for the real, you guys, that's 1, 2, 3, 4, 5, right? And your guys' imaginary is 3. 1, 2, 3. So it's 5, 3. And then you guys have these doyos. So for the doyos, you guys, it says negative 2 minus 4i. So negative 2 is the real, so 1, 2. And then negative 4i is imaginary. So down 4. 1, 2, 3, 4. And there's your guys' imaginary. Plotting part C. Negative 4 for the real, 1, 2, 3, 4, and 3 up for imaginary, 1, 2, 3. Negative 4, 3. And lastly, D, that's 8 to the right and 7 down. Right there. So that's how you guys graph your guys' complex numbers. The first number is your real, and the one attached to the I, that's your guys' imaginary. Okay, powers of I. Because the powers of I will cycle through 1i, negative 1, and negative I, we can use the pattern below to simplify I to the n power. So here is your guys' powers of I. So as you guys can see, it goes 1i, negative 1, negative I, and then 1, and then it just keeps on cycling. So I to the 5th would be I to the 6th would be negative 1, I to the 7th would be negative I to the 8th would be 1, and so forth. So always repeat that pattern. Now, a clever way to remember these right here, you guys, is this. I1, negatives in the middle. And if you're like, I don't understand, this is a mnemonic device that will help you guys remember these formulas. So you guys read this, like literally read this along with me, right? What is this? This is I. If you do not include the negative sign, isn't that a 1, right? So I, the number 1, I, the number 1. I1, and do you guys see where it says negatives in the middle? The negatives are in between. They're in between, or they're in the middle of the other two. So this will help you guys remember this, because, right, if you guys were to remember this on an exam or something, right? I to the first, I to the second, I to the third, I to the fourth. I1, and negatives in the middle, right? It's a clever way to remember that stuff. Okay, so now I'm going to show you guys how to simplify. Now, if you guys just saw this, you would not know how to solve for this, right? But take a look. The highest number you guys know is I to the 4th, right? The highest number you guys know for I powers is I to the 4th, right? So why don't we use I to the 4th to inch closer and closer to I to the 21st, right? I to the 4th. Are we at 21 yet? No, so we gotta keep on adding more I to the 4th. Are we there yet? No, 4 plus 4 is 8. Are we there yet? No, that's 12 i's in total, 16 i's in total, 20 i's in total, and then to actually reach 21, you guys, it would be I to the 1st, right? So again, we don't know what i's 21st is, but we do know what I to the 4th is, right? And all the ones from 0 to 4. Now, this is what we do. Isn't I to the 4th power, you guys, 1? Right? So can't we replace multiplying all these together? Can we replace all those I to the 4th by 1? I to the 4th is 1. Isn't that I to the 4th 1, that I to the 4th 1, that I to the 4th 1, and that I 4th to the 1, right? And then what's I to the 1st, guys? Well, look at your notes, right? I to the 1st is just I. So what we really have is 1 times 1 times 1 times 1 times I. And if you guys multiply all those ones together, that's just 1 times I. And what's 1 times I? I. So I to the 21st, you guys, just simplifies to I. And again, we used I powers that we do know, right? We use I powers that we do know in order to get a higher I degree power. Let's look at I to the 34th, okay? I to the 4th, because we don't know what this is, right? So we're going to use I to the powers that we do know in order to represent I to the 34th. I to the 4th, that's just 4 i's. That makes 8 i's. 12 i's, 16 i's, 20 i's, 24 i's, 28 i's, 32 i's, and then 34 i's, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. So all of those, you guys, multiply together, that adds up to be I to the 34th power. But then remember, all of these ones, right? All of these I to the 4th, you guys, they're equals to 1. But then what is I to the 2nd? Well, by definition, we know I to the 2nd equals -1. So once you guys multiply all those ones out, don't worry, just left with 1 times -I, and 1 times negative, or 1 times -1, and 1 times -1, you guys, is -1. So I to the 34th, you guys, is -1. Now, if we look at I to the 100th, do you guys really want to write down 25 I to the 4ths, right? So there must be a quicker way to do this, and it's this, you guys. I to the nth power is equals to I to the remainder power. And you divide n by 4, and that will determine the remainder. So, you guys watch these, right? Well, isn't this the power, you guys, right? And if you divide 21 by 4, 5 times 20 is 5 times 4 is 20, and you guys get a remainder of 1, right? You guys get a remainder of 1. Based off this, we put I to the power of the remainder. So this is actually I to the 1st power, because that's the remainder. And then what is I to the 1st? Just I. And it's the same thing that we got here. And this makes sense because, look, you guys, what does this 5 represent? That represents how many I to the 4ths we have. 1, 2, 3, 4, 5. And all those turn to 1s. And then look, the remainder is the answer of our problem. But let's do another one. So this is a shortcut way. Take the power and divide it by 4. 4 goes in 34 8 times with a remainder of 2. So this is going to be I to the 2nd power, which is -1. If You see how quick that is, you guys, as opposed to writing down all of the I to the 4th and the remainders, right? You just take the power and you guys divide it by 4. 4 goes into 10 twice. 4 goes into 20 5 times. So there is no remainder here, you guys. So that means I to the 100 is going to be I to the remainder, 0 power, and I to the 0 power, you guys, is 1. And I to the hundreds is just 1. Try D, right? 43 divided by 4. 4 goes into 4 once. And 4 goes into 3 0 times. So our remainder is 3. So I to the 43rd, you guys, is going to be equal to I to the 3rd power. But what is I to the 3rd power? Negative I. And that is your guys' answer. So make sure you guys do these 1 through 5s, right, for all your problems, and write one thing new you guys learned, and you guys should be good, okay? Alright, good luck on the homework assignment, you guys, and yeah, peace.